Hello, and thank you for choosing this video on matrix-assisted laser desorption ionization with time-of-flight mass spectroscopy, also known as MALDI-TOF. I am Mac Majors, and this is my presentation for Dr. Kreller's Instrumental Analysis class at Georgia Southern University. MALDI-TOF is a fairly new instrumental technique that is still being found to have many multiple uses in mass spectroscopy. The technique is used to find molecular mass through laser desorption and ionization. The compounds most suitable for MALDI-TOF are large compounds such as proteins and peptides. This technique is also considered a soft source due to the compounds not being fragmented in the process of analysis. To the right, that picture is a picture of what a MALDI-TOF may look like. MALDI-TOF works by placing a droplet of sample and droplet of matrix on a steel plate and allowing the droplet to air dry. Once dry, the plate is placed into the instrument for analysis. Picture on the right is an example of what a plate would look like. The laser is shot at the sample, creating a plume of sample and matrix. The energy from the laser is absorbed by the matrix, and that energy is then transferred to the sample, ionizing it. The ions created travel up through the TOF chamber due to an electric field. The ions travel at different speeds through the chamber to the detector. The detector sorts the ions by mass, and the smaller the ion, the faster it will be detected. The picture to the right shows the laser creating the plume. This is a diagram layout of the MALDI-TOF. One shows the sample plate containing samples and where it would be located. 2 is the laser that desorbs and ionizes the sample. 3 is the drift tube, where the electric field is located and the ions travel up. 4 is the TOF chamber with the detector. 1 through 4 are all located in a vacuum. And 5 is the computer that shows readout and communicates with the instrument. As previously stated, the TOF detector sorts the ions by mass to charge ratio, where smaller compounds are detected first. This example shows the relative intensity on the y-axis and the mass to charge ratio on the x-axis. Small to charge molecules are read from left to right. The quantitative information found in these signals are told by the y-axis in peak height and peak area. Qualitative information is found through the x-axis of mass to charge ratio. MALDI-TOF is used regularly in research to find molecular mass of proteins. This research article, MALDI-TOF MS Analysis of Native and Permethylated or Benzimidazole Derivatized Polysaccharide, uses MALDI-TOF to analyze polysaccharides. The researchers were trying to find a way for polysaccharides to be analyzed by MALDI-TOF with more sensitivity. They analyze native polysaccharides, derivatized polysaccharides, and benzimidazole tagged polysaccharides. They use the dry droplet method, which just means they let the sample and matrix droplet air dry on the steel plate, and they used a standard 2 microliter sample size. The results of their research include these MALDI-TOF spectra. The examples I have provided are of the polysaccharide glucomannan. Each spectra are of native, permethylated, and BIM derivatized glucomannan. The article reported that permethylated polysaccharides provided the strongest intensities in the measurement, while they believe BIM derivatives of the polysaccharides have both signal enhancement and stronger visibility. These are my references, and thank you again for choosing this video on MALDI-TOF.